This is Professor Pelton. This is Algebra 2, Chapter 7, Section 3, Multiplying and Dividing Rational Expressions. Rational expressions are when you have two polynomials. Obviously, they're non-zero, okay? And it's a quotient of the two. So if it is a quotient, fraction, your denominator can't be 0 because you can't divide by 0 because that would be undefined. Thus, you have to limit the domains with rational functions, unlike regular polynomials, because of the fact you can't divide by 0. So in the first example, we have x minus 2 on the denominator. So we can get our pen to work here. X minus 2 cannot equal 0. Thus, x cannot equal 2. So our domain is all values of x except for 2. So going least to greatest, negative infinity to 2, union 2 to infinity. Okay. Next one, x squared minus 1 cannot be 0. So x squared cannot equal 1. So if I square root that, x cannot equal plus or minus the square root of 1, right? Because it's an even root, you have to do plus or minus. So x cannot equal plus or minus 1. So my domain here, going least to greatest, can be every value except for 1 and negative 1. So negative infinity to negative 1, union negative 1 to 1, union 1 to infinity. Okay. And lastly, the denominator of this one, x squared plus 3x minus 18, cannot equal 0, but that's a factor of 1. It's a 1 right there, right? Okay, so that's 1x, all divided by 1, and negative 18. Let's see, negative 18, break that up. That's going to be what? 3 and 6. It'll be a positive 3 and negative 6. That'll give me a negative 18 and a positive 3 in the middle. Okay, so therefore, x minus 3 cannot equal 0, and x plus 6 cannot equal 0. Thus, x cannot equal 3, and x cannot equal negative 6. Okay, so our domain is, let's see here, didn't leave myself enough room. We'll scooch it down a little bit, actually, because we get a lot of parts. Domain. Okay, least to greatest. Negative infinity to negative 6, union negative 6 to 3, union 3 to infinity. All right, we got it all in there. All right, pause the video, do the student problems for yourself. Okay, student problems. First denominator, x plus 5 cannot be 0, therefore x cannot be negative 5. So my domain is all values of x except for negative 5. So negative infinity to negative 5, union negative 5 to positive infinity. Okay. All right, next one, x squared minus 36 cannot be 0. So x squared cannot be 36. So if I square root both sides, x cannot equal plus or minus 6. So my domain here is negative infinity to negative 6, union negative 6 to 6, union 6 to infinity. Okay, because remember these need to go least to greatest. Okay, last one, factoring here. So that can't be 0 on the bottom. So we have our factoring brackets. So we have 1x, 1x, 1 on bottom. Factors of 14. Let's see, 2 and 7 should work for us. 2 times 7 gives us 14. If 7 is negative and 2 is positive, so as a result, we get negative 5. So x plus 2 cannot equal 0, so therefore x cannot equal negative 2, and x minus 7 cannot equal 0, therefore x cannot equal 7. Okay, so our domain, least to greatest domain, is negative infinity to negative 2 union, come on, union negative 2 to 7 union 7 to infinity. Okay, so simplifying, now let me know there's restrictions on the domains. That applies to all problems with rational expressions. Okay, so you cannot have a common factor other than 1 in the numerator and denominator. Basically, the process is to factor the numerator and the denominator completely and divide by the common factors, other than 1, of course. Okay. Okay, so the top one has a common factor of x squared, which we can factor out. So that leaves me with x plus 1. And I also have an x plus 1 on the bottom, which cancels out and leaves me with a simplified x squared. But it's only true where x cannot equal negative 1. Okay? Because if you plug in negative 1 to the denominator, you will get 0, and that cannot happen. So you have, again, limited domains on rational expressions and functions. Okay, next one we'll factor. So let's see, the top is going to factor into 1x, 1x. I won't put the 1 on the bottom this time. Factors of 5 are 1 and 5. They both need to be positive to get positive 5 and add to 6. On the bottom, we really have x squared plus 0x minus 25. Okay, so if I do that out, that's x plus 1, x plus 5. And on the bottom, if I factor that out, 1x, 1x. So it's 1 times negative 25. So the factors are 5 and 5, plus and minus. Okay. Okay, because we need factors of 1 times negative 25. Which ones will give you 0? It's going to be 5 and negative 5, obviously. So you really don't need the ones in this case either. If it was not a 1, it would matter to divide by that number. But we'll leave them off for this case just so they look similar. So in this case, we have an x plus 5 in common. So we have x plus 1 over x minus 5 is the simplified expression, whereas only true where x cannot equal 5 or negative 5. Okay, even though the negative 5 would not be in the final expression, it was in the original one, so you still have to count that. Okay, all right, and lastly, this one is 1x squared plus 0x minus 16 on the top. And on the bottom, I have x plus 4. So it's 1 times negative 16. So the factors of negative 16 that'll give you 0 are x and x, 4 and 4, plus and minus x plus 4. Okay? Because again, 1 times negative 16 is negative 16, so the possibilities are 1 and 8. 1 and 16, 2 and 8, 4 and 4, and one of them has to be negative, and the only combination that gives you 0 is this combination, obviously. So those cancel, giving us a final answer of x minus 4, but it must be true that x cannot equal 4 or negative 4. Okay? I'm sorry, just negative 4. What am I saying? Because in the original problem, if you plugged in negative 4, you would get 0 for the denominator. So again, it could be what the final expression is or the original expression if they pay attention to what the denominators are and what cannot be. Okay. All right, pause the video, try the student problems for yourself. Okay, so in the top one, we can factor out an x squared. So we have x plus 3 left over an x plus 3. So sometimes it's factoring like quad form factoring. Sometimes it's just a matter of factoring out because there's many versions of factoring. There's also the trinomial factoring. Okay, so those cancel, leaving us with a final expression of x squared where x cannot equal negative 3 because of the original denominator. Okay, next one, this is x squared or 1x squared plus 0x minus 1, and we factor on the bottom, quad form factoring. Let me get that line out of there. All right, so we have 1x and 1x, and then that's 1 times 1 for 1. The only way to factor that is, right, because that gives you 1 when you multiply them. It's 1 and 1. And they have to both be positive to get a positive 1 when you multiply and a positive 2 when you add. Okay, so we'll factor the top now. So we have x and x. 1 times negative 1 gives you negative 1. The only way you can factor negative 1 is negative 1 and positive 1, which gives you 0 on the top. So those cancel, giving us a final answer of x minus 1 over x plus 1 is our final expressions. However, where x cannot equal negative 1, and that's true of the original and the final expression, that must apply. Okay. All right, lastly, we got a 1 there and a 1 there, so we'll factor it out. So 1x, 1x, 1 times negative 3 is negative 3. The only factors that work here are 1 and 3, but one of them has to be negative, so the 3 will be negative. So it'll add up to negative 2 and multiply to negative 3. And then here 1x and 1x gives me my 1x squared. And then 1 times negative 6 gives me negative 6. So the only thing I can do there is 2 times 3 with a negative 3 and a positive 2 will give me my negative 1 middle term when added and negative 6 when I multiply. So as a result, the x minus 3's cancel, so I get a final expression of x plus 1 over x plus 2, where x cannot equal negative 2 or positive 3. Okay, whoops, let me get rid of that there. Because the original function had 2 values that could zero it out. All right, that is the end of part 1